am Sagar, Assistant Professor, Department of Mechanical Engineering from Chaitanya deemed to be University, Warangal. Today we are going to discuss engineering graphics and design subject, one important topic called conic sections. The curves used in engineering practice is a syllabus coverage, and we have conic section curves and cycloidal curves. So what are conic section curves? How many are there? Conic section curves are generated by the cone when it is cut into different cross sections. First one ellipse, second one parabola, and the third one hyperbola. And if you talk about cycloidal curves, first one is cycloid, epicycloid, hypocycloid, and involute. So these are the total 7 curves we have to discuss. In this video, I am going to discuss only about ellipse curve, how to draw ellipse using general method or eccentricity method. So first of all, we will talk about conic sections. What is a cone? How a cone will be? What a cone has entities. So a cone has a base as circle, and it has generators, and it has a center, and it has vertex, and it has apex. Okay. So when you talk about ellipse, ellipse is a curve which is generated when the center of the cone is intersected by a section cutting plane. The curve generated is nothing but ellipse. So when I'm talking about parabola, parabola is nothing but when you take the same cone and when you cut the cross section until the by reaching the base, then the curve generated is nothing but parabola. And when I'm talking about hyperbola, without intersecting the axis, when you're trying to cut the cone exactly parallel to the axis, then the curve generated is nothing but hyperbola. So how to draw conic sections? We use general method or eccentricity method. You know this word eccentricity? Eccentricity means that it's the ratio of distance of point from the focus to the distance of point from the directrix, and it is denoted with alphabet small e. Okay, everybody, small e is equal to the ratio of distance of point from the focus to the distance of point from directrix. Now, depending upon this eccentricity value, we can decide which curve it is, either ellipse, parabola, or hyperbola. So, if I am talking about ellipse, e is less than 1. The eccentricity value, the value of eccentricity which is given is less than 1, it is called ellipse. So, if I am talking about parabola, e is equal to 1 tells you parabola. If e is greater than 1, then we call it as hyperbola. Today we are going to deal only about conic sections. In the further videos, I will be explaining you about different cycloidal curves also together. So let's see one problem in ellipse general method, or you call it as eccentricity method. So here we have a question: construction of an ellipse when the distance of focus from the directrix is given as 50 mm and eccentricity value is 2 by 3, and you need to draw the tangent normal. Yes, okay everybody, take your drafter, put it in 0 and take a 2H pencil and draw a vertical line which is called directrix, name it as D dash, and now draw a horizontal line in the directrix line, that will be your axis, name it as point A, and take 50 mm on the horizontal line and locate focus. F is nothing but focus. Now AF is the line which is of 50 mm, divide into 5 parts because the eccentricity value is given to you as 2 by 3. 2 plus 3 is 5, so you need to do 5 parts. 50 by 5 you get 10 mm. So for every 10 mm put a point and locate 5 points, give the numbering, and you can locate the vertex by using numerator or the denominator. Distance of focus and distance of point from the directrix. So you get on the second point from the focus side, if you see 2 points below, you get vertex, and if you take from the left side on third point you get vertex. Now VF is 20 mm, take VP also 20 mm and join AP and extend. Now after joining AP, do the same towards AQ and also extend. So you get 2 cross lines joining AP and AQ. Now as you wish, you can put some number of points after vertex V as maybe equidistant, or you can take your own way and take number of lines like 1, 2, 3, 4. You want taking points. Here if you see one dash line has been plotted. Now one dash radius, F as center, you take your compass, F as center, one dash radius, you need to draw 2 arcs on one dash line. Next 2 dash point line is there you have. Now take your compass, 2 dash radius, F as center, cut it on 2 dash line above and below. In that way take P2 and Q2. So next go to third point, and next third point you take it and draw the line towards AP, and that will be your 3 dash point. Take 3 dash radius, F as center, draw an arc above and below. F as common center for everything. In the same manner, 4 dash radius, F as center, locate fourth point, 4 dash radius, F as center, you need to draw one more curve. So in this way, simultaneous actions to be taken, 4 dash, 4 double dash, you can take. F as center, now cut the arc using 4 dash radius. Okay. Next, take one more point. In this way, plot whatever the curves you are cutting the line, name them with P and Q notations. Now, in that way, take fifth point and draw a line towards AP and AQ. Now, from 5 dash radius, F as center, simply do the same procedure of cutting the arcs on the lines. In this way, you do cut the one by one, you do cut each and every line. So, at one particular point of time, you get the closure of the curve. So soon as the focus has been fixed, so the distance between focus and the point number 6, 7 in that way will be reduced. It meets the axis at a point. So that's the closure of the curve of ellipse. So this can't happen in parabola and hyperbola. The point number 6 we have taken, and now point number 7. So seventh line will be drawn by taking 10 mm gap. You can take equidistant or non-equidistant also. Now same procedure, 7 dash, 7 double dash, 7 dash radius, F as center, draw two curves on above AP and below AQ. So in this way you get P7 and Q7. So on, if you do like this, 8 point, 9 point, somewhere you will reach closing from the line, that curve we will be taking here at P7 and Q7 it's over. Now P8 and Q8 point you will be getting. Next we will take 10 mm again, and you will be taking 8th point, you will be taking 9th point, and you will be drawing one more line which is meeting AP at 9 dash and AQ at 9 double dash. Now F as center, 9 dash radius, you are going to take from focus and you need to draw two arcs, that will be P9 and Q9. Next what you are going to do is, next again you take one more 10 mm and go for the next line. And take one more 10 dash and 10 double dash line, and now 10 dash and 10 radius, F as center, you need to take one arc above and one arc below, that will be P10 and Q10. In this way you get number of curves. On each and every line you need to take above and below points P and Q. So in this way you continue to go up to 10, 11, 12 until and unless the curve is been closed. So I have taken 11 dash radius, F as center. So it is nearing like P11 and PQ11. So now lastly we have 12th point. 12th point is same as usually drawn, general method. Now 12 dash, you get 12 double dash also. Now what you're going to do, 12 dash radius, F as center, F is the center, draw an arc, that will be your closure point from the focus. Now join from the vertex using your H pencil and close it so that you get your required ellipse. Now I am talking about tangent and normal. Now 40 mm is a point we will take anywhere. So we have taken X is the point. Now join it with the focus. From the focus, draw a perpendicular line towards the directrix. So when you draw a line towards directrix, the line meeting point you get, it will be considered as B. Now join X and B. So when you join X and B, use your H pencil. That will be your required tangent, and on that point if you take a perpendicular, that will be your normal. So in this way you are going to generate your ellipse by general method. So this is your methodology of drawing ellipse. So hope everybody have understood it clearly. That's all for today. The topics will be discussed in the next video. Thank you.